Hey all, it's Miss Gross. We're doing lesson 4, scaled relationships. Our learning target is I can use corresponding distances and corresponding angles to tell whether one figure is a scaled copy of another. Before you proceed, make sure that you have lesson 4 in for your guided notes on your red notebook. And let's go ahead and get started. All right, so corresponding distances. For this, we got to figure out what the scale factor is. And remember in lesson 3, we learned that the scale factor is the multiplication, the multiplicative. So we do whatever this is times what will give you this. That would be the scale factor. So I would start with the easy. I would start with like BC or FE or even BF. So let's look at BC. This right here is 2. Let me use my pen here. And then right here, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6. The distance here is 6. So 2 times what would give you 6? And that would be 3. So the scale factor would be 3. So this is every single part of this is going to be 3 times bigger than this. All right, this says the distance from T to X. So we want to go from T to X is what? 1, 2, 3, 4, 5, 6. Oh, that one's also 6. That should be easy to know. So if that's 6 and that's 6 are the same, which is blank times bigger from B to F? Well, from B to F is only 2. So 2 times 3 would give you 6. So it's 3 times bigger. Again, the scale factor would be 3. If you need to pause the video, take notes before we move it on, you can. But if not, we'll go ahead and move on to the next slide. Uh-oh. How do I clear this? Oopsie. I know there's an easier way. All right, so the next slide is the corresponding angles. So we got to figure out our corresponding angles here. Sorry, this should have been a whole lot easier. And I know there's an easier way. Okay. All angles in a scaled copy have the same measure as the corresponding angles in the original figure. So write in same measure. So let's look at it. If you look at these two triangles, even though this one is larger, look at the angles. They're the exact same. This is 60, this is also 60. 78, this is also 78, and 42 is also 42. So all angles in a scaled copy have the same measure as the corresponding angles in the original figure. Okay, go on to the next part, scaled or not scaled. So we are going to look at these two figures and we're going to see if they're scaled or not scaled. So let's first start with the, in order to know if it's scaled, the corresponding angles have to have the same measure. Well, good news is the corresponding angles are the same because these are all 90 degrees because they're both rectangles, but the corresponding lengths have to have the same scale factor, and they don't, because if you look, if you want to multiply 2 to get 1, it would be half, right? Because half of 2 would be 1, so this is half. But if you multiplied 3 by half, you would not get 2. 3 by half would be 1.5. So 3 times 2/3 would give you 2. So that would be different. So therefore, they would not be the same. The second rectangle is not a scaled copy of the first rectangle because they have different scale factors. All right. So let's recap. When a scaled copy is created from a figure, we know that the distances between any 2 points in the original figure, even those not connected by the segments, are scaled by the same scaled factor. They have to be. And we also know that the corresponding angles in the original figure and the scaled copies are congruent. And congruent means the exact same measure. Okay? Let me know if you have any questions and hope you have a great rest of your day.